Hello world, it's me. I have a new buddy, which in and of itself is always something to celebrate, but this new buddy sent me some very interesting items, and they each deserve their own video, and we'll get to them in time, but since one of the items is going to be the basis of a new project, I wanted to get to it first. I really won't get into the project until the next video. This video is just a background on the Fairchild F8 that'll be used as the processor in that project. When I think of obscure things from the 70s, first things that come to mind may be the Volkswagen Thing, Chia Pets, Pet Rocks, and Streakers. Then way down the list would be Fairchild's quirky little F8 system. What we're looking at here is a second generation F8, the Mostek MK38P70, which we'll get to in a bit after we talk about the original F8, the 3850. Now, Fairchild's F8 3850 was a lot like the 8080 in that it required multiple power supplies. It took a real engineering effort just to get a system going. At that time, they just couldn't put enough capabilities on one chip and get reasonable yields, so a system would be comprised of multiple members of the F8 family. At the very minimum, a basic system needed the 3850 CPU and a ROM, which had to be the 3851 Program Storage Unit, or the PSU. This would provide something along the lines of 64 bytes of RAM, 1K of masked ROM, and many I/O pins. To create a more capable system, you would then add more F8 components, like a RAM controller, a communications controller, and so forth. But everything needed to be from the F8 family. We'll get to it in another video maybe, but the F8 family utilized a private local bus and a secret handshaking to communicate between devices and keep their internal registers synchronized and exchange data. And, keep that in mind, and many of the F8 programming concepts will make much more sense, like when they say something like all DC zeros will be set. What they're referring to is the DC zero register in all chips in that F8 family will be set. The F8 was announced in 1974, it shipped in 75, and as production ramped up, prices quickly fell. In the spring of 76, the F8 set of the 3850 CPU and the 3851 PSU had a price reduction from $149 to $83. That very summer, when upgraded versions were released, pricing for the original F8 CPU and PSU further dropped to $10 each. So you could make a minimum system for 20 bucks. The F8 was being adopted, production was increasing, and maybe coincidentally, but these price drops came just as word of Intel's competing 8048 microcontroller started to leak out. The 1970s were a time of significant change with companies coming and going. Kind of like the .com, there was the microprocessor boom. Because of this uncertainty, any system integrator would require that their suppliers have a second source for critical components. So, for example, if you were designing a product line around the Z80, you'd want to know that there's going to be a source of that Z80, and should Zlog decide to call it quits, go down the tubes, or be acquired by another company. Of course, Centertech and Mostek filled that role as providing contract manufacturing of somebody else's design. Likewise, AMD, National, NEC, Siemens, TI, and others were second sourcing the Intel 8080. As production was ramping up, prices were falling, and Fairchild was having a whirlwind F8 introduction and education tours. They were traveling all over, giving these little seminars on the F8. This marketing was so effective that by 1977, the F8 had become the world's best-selling microprocessor in a sea of microprocessors from dozens of startups and nearly every established microchip maker. Mostek had their own microprocessor, the 5065 I think it was, but Mostek was more of a power player in memory, even though they weren't up and coming as a contract fab house, meaning a contract fabricator that manufactures chips following designs and recipes provided by the original design owner. So anyway, in about June of 75, and that was even before Mostek was making the Z80, Fairchild made an agreement with Mostek to be their second source for the F8 product line, including the 3850 CPU and the supporting chips. Now the F8 may have been one of the very first microprocessors, but a footnote in the history books will tell the backstory of how Fairchild was also forced into an agreement with Olympia Work in Germany. And this was the result of an intellectual property lawsuit filed by General Instruments Corp, claiming that Fairchild utilized technical know-how that was supposed to be transferred from Olympia into General Instruments, but it was actually transferred from Olympia into Fairchild by David Chung. Supposedly, the story goes that while working at General Instruments, David Chung went on a technical transfer visit to Olympia to obtain intellectual know-how from Olympia on how to make this processor. The lawsuit claimed that after the technical upload part of the transfer, David Chung left General Instruments and began working for Fairchild, where he did a technical download. The suit claimed that Fairchild used this information to create the F8. In an effort to clean up this mess, Fairchild licensed the needed technology directly from Olympia. This whole saga was reported quite thoroughly by the trade journals. You can find a lot of information on it at first, but then the drama just seemed to go away. So evidently Fairchild's license with Olympia did the trick, and it made the backstory completely moot. I bring this all up because the whole development effort seemed to be a risky venture for all concerned. In the 75-76 time frame, all parties to this technical menage a trois seemed to be struggling to stay afloat. Fairchild's 1976 year-over-year earnings were down 71%. General Instruments were down 50%, Mostek's down 70%. So it looked a little doubtful that anyone was going to survive much longer without some kind of a lifeline. And nobody in this group was in any surer footing than anybody else. Meanwhile, Motorola's were up 190%, Intel up 53%, National up 57%, Harris 153%. So the Mostek, Fairchild, General Instruments problems were not simply the result of Nixon's recession, since the financial strains were not industry-wide. In 1976, Mostek had begun manufacturing the Z80, of course even before Zilog did. So they certainly had the manufacturing capability and capacity and knew their way around microprocessors. But considering Mostek's sad state of finances, choosing them as a second source sure seemed like it was a risky move. But eventually Mostek was able to arrest their year-over-year earnings free fall, and by July of 76, Mostek had turned around its earnings and showed a 191% increase in earnings and a 50% increase in sales. So perhaps the Z80, turned their balance sheet around and saved Mostek from going down the tubes. Fairchild's earnings were still down 13%, but their sales were up 60% in sales. So, things were starting to look better, but when you're losing money on each sale, you can't make it up in volume. The Nixon recession was winding down, and despite the Nixon inflation holding on, pretty much everybody in the industry was doing really good. But Fairchild's F8 family, not so much after 1977. It was getting long in the tooth, and it was about to face some serious competition from Intel's 8048. So let's go back to the agreement with Mostek to second source the F8. Mostek had compatible manufacturing processes, so there shouldn't have been a great deal of technology transfer or need for Mostek to ramp up. Maybe Fairchild was desperate, and Mostek had a great negotiator, because with that agreement, Mostek walked away from the table with some pretty powerful rights to Fairchild's design. And quite remarkably, it seemed that Mostek even had the rights to continue development of the F8 as their own technology starting from Fairchild's. The key point is that at some point, both Fairchild engineers and Mostek engineers each decided they could come up with a better solution than the original F8 family for the next generation. Now keep in mind that semiconductor manufacturing technology was progressing extremely quickly, and what seemed like fantasy in 1975 would become achievable in 1976 and become child's play in 1977. It's important to note here, remember that F8 3850 CPU required the 3851 PSU, the program storage unit, which was their ROM, and the 3851 was a custom chip that contained the factory masked ROM. So the end user would ship their programmed EEPROM or their HP 2640 cartridge or paper tapes or cards or their handwritten coding from the truth table printed in the back of any of the Fairchild memory catalogs. You'd mail these to Fairchild, and months later you'd receive back your custom ROMs by return mail. To understand the ramifications of the 3851 being a custom chip, it's important to know a bit about the semiconductor manufacturing process and how Fairchild priced themselves out of that business. Now, manufacturing the semiconductor is a sequence of additive and subtractive steps like metal and oxide depositions or various etchings, which with each of these processes, the first step is to create a masked pattern on the wafer, so the process only affects the unmasked regions. So briefly, you create a design, you transfer that to a film, you do a reduction transfer of that in a metal pattern onto a glass or a quartz plate. Then you would use that plate to transfer the pattern onto the wafer in a resist of some sort, and typically photoresist at that time. The photoresist defines area on the wafer that now exposes the target areas. Then the deposition or the etching process is completed, and it only affects those target areas. The mask is then stripped off so the wafer is ready to be remasked with the pattern for the next process. Now, anybody in their right mind making a custom device would design the manufacturing process so there were a minimum of custom steps required, and furthermore, whatever custom steps there were, you design it so that those would be the last steps in the entire manufacturing process. That way you can make the chip, say up to the 95% completion stage, at any time the fab line schedule is slack, and then you'd put those unfinished wafers in inventory. When somebody orders their custom version, you take these 95% chips off the shelf, do the last processing steps, dice them, mount them, bond them, and ship them out. This minimizes the order to delivery time since only the last few steps require fab line time. Equally important, if the customization of the ROM can be done with a single quartz mask, then there's only one non-recurring engineering charge for that one mask. And at the time, each custom mask cost $1,000 in NREs, giving a definite time and money advantage to this late stage customization concept. But Fairchild didn't take this approach. I don't know which of Fairchild's other ROMs were like this, but for some reason, the Fairchild model for the 3851 and the second generation 3859 was to design the custom ROM masking into the chip very early in the manufacturing process, which required carrying that customization through each subsequent step. And as a result, a customer had to buy a total of 10 or 15 masks for each of these custom ROMs, and they had to wait much longer because none of the steps could be done before the chip was actually ordered and the ROM finalized. Now, in their defense, the Fairchild 3851 was unique in that there was more to customization than just the masked ROM. The configuration of the ports were also specified by the customer to be either open drain, pull up, or drive up. And we'll see more about that later when we start the project design. But it's likely there just wasn't room on the wafer to build all the configurations for the ports and then choose which port driver you're going to use late in the manufacturing process. So they may have had this backwards thinking process because of the customization of the ports. And I haven't seen that detailed anywhere, so it's just a hunch to defend what would otherwise be an incredibly poor engineering choice. So that was 75, 76, but with the higher chip integration that was now possible in late 76, Fairchild's solution for the next generation F8 was to combine the 3850 and the 3851 and integrate them into one chip, and that became the 3859. But Fairchild held on to the concept of customizing the chip early in the manufacturing process, so there were still unusually high NREs and long manufacturing lead times. Again, $10,000 to $15,000 worth of NREs in each custom part. By the end of 1976, Fairchild announced their 3859 would ship the first quarter of 1977 for under $20 plus this $10,000 or $15,000 in NREs. For this second generation F8, Fairchild entered into an agreement with Motorola to reciprocal source. Motorola would make the 3859 and Fairchild would make the 6800. I presume it would come as a surprise to Motorola when Fairchild would later kill the 3859, and that would be entirely thanks to Mostek. And that was because over at Mostek, they had started with more of a blank sheet approach concept when they set out to create their version of the next generation F8. And it's still remarkable when you think that Mostek's second source licensing would allow them to independently and freely engineer follow-on devices that were based on the Fairchild design. So they obviously had the rights to do cooperative engineering with Fairchild to jointly create the next version, but Mostek had these rights to make an independent version because now in 1977, Fairchild and Mostek both had announced their respective second generation F8 microprocessors, each of their own design. Just like Fairchild, Mostek started releasing information about their design and announced that it would be available in the first quarter of 1977. And they promised prices under $10 in quantities of 100, half the price that Fairchild had just announced their second generation F8. In addition to price, there were two critically important differences in these two chips. First of all, as I mentioned earlier, Fairchild continued their process that required customization early in the manufacturing process and all the costs associated with the suite of customized masks and long lead times. The Mostek process allowed customization late in the manufacturing, so they were able to have a fraction of the NREs and delivery time. Specifically, for a customer getting a second generation F8 from Fairchild, there was still the $10,000 to $15,000 NRE charge. And that's $40,000 to $60,000 in today's dollars. To get the second generation Mostek F8, there was only a $1,000 NRE charge and a much shorter lead time because chips could be pre-made. In addition to the acquisition cost, to further differentiate between the products in addition to price, just like Intel did when they went from the 8080 to the 8085, and also with the 8048, and Zilog did with the Z80, Mostek eliminated the need for multiple voltages and brought the chip to a single 5-volt power requirement. The 3859 still required plus 5 and plus 12. Now, I don't know how Fairchild thought it was a good idea to release a new microcontroller in 1977 that still required multiple power supplies. So there was price, there was the single power supply, and then as gravy, the Mostek chip was faster than the Fairchild 3859. It had double the ROM, it had 2 kilobytes versus the 3859 1 kilobyte, and it had an internally executable program RAM. So not just scratchpad RAM like the typical F8, but it had RAM that could hold executable code. So I'm guessing that the next meeting between Fairchild and Mostek may have been fairly awkward when Mostek brought out their 3870, which was twice as fast as Fairchild's, had a tenth the NREs, it only required a single power supply, it was fully F8 software compatible, and it was an overall superior device. So after seeing the Mostek solution, Fairchild canceled their 3859 combined chip, and presumably, with hat in hand, goes back to Mostek to now seek a second source agreement for Fairchild to manufacture the Mostek's second generation F8. So, what comes around goes around, as they say. So everybody was happy again making chips, at least for a while, until United Technologies takes control at Mostek and leading to that train wreck. So this 3859 was the final result of that story. This is a 3870, it's Mostek's version of the F8 as a microcontroller with customer-specified custom masked ROM and customer-specified port configuration. And no, this isn't what my new buddy Will sent to me. This is one that somebody sent me to dump the ROM contents, which makes me wonder. I need someone to explain to me why people have any interest at all in these masked ROM devices. For every one of these has custom code and custom port configuration that were specific to a specific product. But there's dozens and dozens of these masked ROM versions of the 3870 being hawked on eBay. Unless you're replacing a lost PROM in an old F8 system, somebody just needs to explain to me how these masked ROMs have any value at all. You can't connect this up to an external EEPROM and run anything. This can only run the code that's in that ROM. So what are people doing with these things that create any market at all? I'm just surprised these aren't winding up in the trash. So that's probably as much background on the F8 as you can stand. But despite its short life, it was a historically significant chip. And in the words of Osborne's introduction to the 8048, he says, the 8048 looks like a one-chip 8080 with heavy F8 influence. The F8 was the first 8-bit microprocessor to bring the economics of low chip counts to the attention of the semiconductor industry. It's therefore not surprising to find a heavy F8 influence in the 8048. Now we're at the point in the story that my new buddy Will became involved. Now I've arranged for the Hello World players to help tell the story. As I understand it, my buddy Will was doing some chip selection for a new project. And my new buddy Will himself had a buddy that was an engineer at Mostek. And since my buddy Will was doing some chip selection for a new project, Will's Mostek buddy gave to Will some early 3870 engineering samples. And he asked if Will would check them out and get back to him with his thoughts. Okie doke. But my new buddy Will got busy with other things and he shelved the engineering samples that his Mostek buddy had given to him to evaluate. So some time passed and now Will, his buddy, and all the rest of us are 45 years older. And as us old people do, my new buddy Will was watching YouTube videos about old-timey electronic things when he remembered the Mostek engineering samples that his buddy had sent him way back when. So after a little digging and cleaning out of his basement, Will found the chips along with some of the other things that he sent me, some prologue information and boards. We chatted a bit, and Will graciously decided to send some of the Mostek engineering samples to me in the hopes that we can design them into something useful. And that would allow us to evaluate them and generate feedback on the Mostek second generation F8. And that catches us up to now. And then whenever we've completed whatever we're going to make, I can send it back to Will so then he can get back to his Mostek buddy that everything is good to go with the 3870 design. So here's a better look at the chips that Will sent me. And It doesn't take a genius to recognize that there's something screwy about these chips. Now we've got two prototype chips and we've got a production chip here. Both of the prototype chips and the engineering test samples have normal pins on the pokey side, but they've also got sockets on the back. And it would make sense that these were some sort of in-house test or development chip, but these were actual Mostek released product called the 38P70, where the P stands for Piggyback. Piggybacking EPROMs wasn't unique to this processor, others did it too, but technical advances made the need for piggybacking obsolete almost as soon as it was introduced. As you can well imagine, this was extremely expensive packaging, compared to just a plastic molded dip. These with the fiberglass circuit board on the back, they're marked as packaging samples. You can see the board is notched, so the ceramic chip itself is just capped as normal, and it looks like there's little balls of something making contact between the circuit board and the chip. Maybe something like silver epoxy or low melt solder or the like. This version of the prototype, the Piggyback, says is for a 2716 EEPROM, and this one's for a 2732 EEPROM. The Mostek part numbers on these are MK3874. And the general idea behind this Piggyback is that before a customer is going to commit to the expense and the lead time for a custom masked chip, it would be nice to know that everything works as intended. So Mostek created these as a tool that would allow the customer to use their own EEPROM rather than, an embedded masked ROM during the product development. So you can program your EEPROM as normal. You plug it into the back of the chip, you run it, the chip reads from this external EEPROM because it doesn't have an internal masked ROM. You test it, you repeat, you continue your development cycle. And then when everything is done and dusted, the customer would just send in, this EEPROM or paper tape or whatever cards or a hex file or whatever they had. They would also include the port pinout configuration because this has customizable ports on it. And a couple of months later, you receive back from Mostek the custom version of your chip. And that would be in this, plastic package. It worked exactly as expected and ready to drop into your product because you've used a equivalent version in your development cycle. And, in fact, until your custom versions arrived, you could ship product with this Piggyback version and an EEPROM. And of course, this concept also worked well for products and customers that would never have sufficient production volume to merit making a custom masked ROM chip. Heathkit, I think, for example, used the Piggyback version in some of their kits. In the end, these P-series with the Piggyback EEPROM saved developers from having to make some jerry-rigged hardware that emulated the final chip. It allowed for earlier product shipping, and life was as simple as getting the P version, probably as a freebie for most, and then go through the standard hardware and code development and testing cycles. Then you could just seamlessly transition over to the masked ROM version of the chip when the custom chips arrived. Now Mostek had devised a very good idea compared to what Fairchild was offering, but meanwhile over at Intel they were putting out the 8048. And with the 8048 it had the EEPROM integrated into the package. So now while it's pretty simple to take out the EEPROM, erase it, reprogram it, and put it back in, it was much simpler to just have that integrated into one package. And as a further advantage, Intel also offered the intermediate step of the one-time programmable devices to satisfy volume requirements between those using the EEPROM version and before you got up to a factory masked version. So you would start out with the EEPROM version, then transition to the OTP, the one-time programmable, then order yourself the masked ROM version as volumes eventually dictated. And in the end, like any of us, the F8 family had served its usefulness and fairly quickly it became obsolete. If you look at the annual microprocessor and microcomputer sales, once Intel's 8048 took hold in 1977, it was introduced in 96, by 1977 it was fully ramped up. Once it took hold in 1977, that was the year that the F8 family was the leading microprocessor, and that was the last year that the F8 family was the leader. The MCS 48 family outsold the various versions of the 3870 every year after that. So ultimately the 8048 evolved into the 8052, and that became the standard microcontroller, and people still use 8052 based embedded microcontrollers. Meanwhile, both Fairchild and Mostek were undergoing corporate changes, and most of the changes being fairly destructive. The F8 fell out of favor, and the quirky little F8 family, including the 3870, withered away relatively quickly. Mostek was gobbled up and spat out, while Fairchild drifted in and out of obscurity. There's no real moral to that part of the story, I suppose, except that everything has a useful lifetime. Okay, now to the project. So it's been quite some time, sort of like 40 years, but my buddy Will would like to get back to his buddy that was at Mostek to give him feedback on this 3870, and perhaps the feedback will still be useful, but most likely not. As is so often the case, a good starting point when learning a new chip is to make a clock. So that's going to be the end goal of this project, a real-time clock using the 38P7 something and support components from the same time period. In the next video, we'll take the project up in earnest and start to figure out the insides of the Mostek 38P70 along the way. Thanks for watching. If you're an F8 guru, let me know, as I'm sure to get bogged down in some details or misunderstand things along the way, have some questions that will just take a lot of digging to answer, and probably go down some dead ends and rabbit holes. As always, this channel is entirely fueled by likes, subscribers, sharing, and viewer engagement. And I really look forward to the next video where we really dig into this F8, start designing the project to resurrect this old 3870. Okay, talk to you later. Bye-bye.